Welcome to Ask and Learn.
So for problem 15.185, we'll be given the velocity vectors for points B and D, and we need to calculate the angular velocity of the bowling ball, and specifically the linear velocity for point C, which is the center of the rolling bowling ball. Now, in order to do this, we need to find a way to relate the angular velocity and the velocity of the center to the velocities, to the velocity vectors of the 2 points. We can do this using relation 15.43 of the textbook. And let's adjust it here for the 2 points. Let's begin with point D for convenience. You'll see in a while why we started with point D. So vector velocity of point D equals vector VC plus cross product of the angular velocity times the relative position vector of point D with respect to C. This is defined, of course, this way. It's the vector difference of the position with respect to the origin of point D minus the position of point C with respect to the origin. Let's do the same for point B. Its vector velocity equals vector VC plus cross product of the angular velocity times the relative position vector of point B with respect to C, which equals, of course, our position B with respect to the origin minus position of C with respect to the origin. So now we have two equations, and let's see how many unknowns. 1, 2. Known, unknown. We know that one, we can calculate it. This one the same. We'll be given this one, we'll be given that one. So we better eliminate one of the unknowns in order to focus on the other and solve for this one. So one way we can do this is to subtract the two equations, and we get the vector difference of the two velocity vectors. Vector VC is eliminated. And then using the linearity property of the cross product, we get this expression. Which though can be simplified if we use the definitions of the relative position vectors. Minus RC, and then minus vector RB plus vector RC. So vector RC goes away, and we're left the simpler expression, angular velocity cross product, the vector difference of vector RD minus vector RB. So then we need to calculate that one and that one, these two expressions, and then we have to solve for the angular velocity. If you do now the calculations, you can see that the difference of the two given vector velocities is just 3.6 I hat plus 4.8 j hat plus 4.8 plus 4.8 k hat. Now what about the vector difference of the two corresponding position vectors. If you check the drawing, you will see that the position vector of point D with respect to the origin is 2 times the radius of the bowling ball, j hat, minus r j hat plus r k hat, again, all this from the drawing. These results, of course, to rj hat minus rk hat. And we need next the cross product of the angular velocity the vector difference of the two position vectors. And this is better to be written in a determinant form. Okay. We don't know the components of the angular velocity. But before we continue, someone might see that there's already a simplification that can be made. We know that the bowling ball is rolling on the xz plane. So this immediately indicates us that the direction of the angular velocity is on this plane. So there shouldn't be an y component for the angular velocity, just zero. The angular velocity is on a plane parallel to the xz plane. Otherwise, the bowling ball will be moving upwards or downwards, which this is not allowed. So I hope the surveys that this determinant gives a result like this one. In which then, of course, equals to the relative difference of the velocity vectors. And if you check the previous result, you might be able to see immediately that the x component of the velocity vector, of the angular velocity vector, equals 4.8 over r, which approximately is 44 radians per second. And the z component of the angular velocity is minus 3.6 over r, which approximately equals minus 33 radians per second. Let's write it more clearly here. I prefer that we keep the r in the expression And this is variance per second. And then in order to calculate VC, we go back to one of the initial equations. Let's pick equation for point D for convenience. So now we can calculate this one. We know that one will be given that one. And that way we can calculate this one. So again, let's write this in a determinant form. And I hope it is obvious that the relative position vector for D with respect to C is just a R. I mean, it might be obvious from the drawing. And I hope again that it is clear that this gives immediately the following result. And now using the initial expression for the vector VD, we can solve for V vector VC. And this gives us 3.6 I hat plus 4.8 K hat. And that's it.